So, one of the most powerful techniques you're going to use with this sampling stuff, and we're going to apply this now, is what we call a simulation. And what does the word simulate look like? What does the word simulate mean, actually? What does that word simulate mean? When you simulate something, what are you doing? You're almost like, yeah, trying to do it though, right? Or, you know what I'm saying? You're trying to mimic it. That's what you're really, a simulation is a mimicking or a mocking of something. So, let's look at this. It says, suppose a cereal manufacturer puts pictures of cartoon characters on cards and boxes of cereal in the hopes of boosting sales. The manufacturer announces that 20% of the cards will have Mickey Mouse, 30% of the cards will have Goofy, and the rest will contain pictures of Donald Duck. You want to collect all 3 cards. How many boxes of cereal do you expect to have to buy in order to complete the set? So, we're trying to collect these cards, right? They have cartoon characters on them, right? Everybody got that? And here's what happens. We're going to develop a simulation from this process. Why can't we, here's what we could do in theory, or in theory, here's what you want to do. You want to collect all the cards. You want to collect all the cards. What would you have to do? Buy a lot of cereal boxes, right? Do we want to do that? Why not?
We don't want to do that?
Why don't we want to do that? Why don't we buy a lot of cereal? It's a lot of money. It's a waste of money, and it's a waste of the actual cereal itself, and we're just collecting for the cards, right? You got that? So we're going to do what's called a simulation. A simulation, we just said, was the, let me get the actual definition for you, because I don't want to mess that up. A simulation is the process of using a sequence of random numbers to model the outcomes of a situation. So in our particular case, we're trying to, what are we trying to model here? What do we want to model here? What do we want to show? What are we trying to get? Somebody help me out. What are we trying to get here? Thank you. So we want to model the actual process of buying boxes of cereal and trying to get what? Cards. And we want to get what kind of cards in particular? 3, the collection, right? So here we're going to the outcomes being modeled here. The outcomes being modeled are the selection of cards, or the selection of cereal boxes, I'm sorry. To obtain a collection of cards. So we want to select these cards. We want to select these cereal boxes in the hopes of when we select a card, when we select the cereal box, we're going to get a particular card, right? And when do we stop selecting boxes? When are we done selecting boxes? When we have all 3 cards, right? So that means we're going to take 3 boxes and we'll be able to stop, right?
No.
No, that doesn't mean that, right? We can't just take 3 boxes and we stop. Think about this in the real world. Any of y'all collect anything? Any of y'all collect anything? Y'all don't look like collectors to me. Well, if you collect stuff, do you ever get everything you want after the first attempt? So we're probably going to have to take more than 3 boxes to do this, right? All right. So here's what we're going to talk about then. In a simulation, here are your key terms. You have what's called the component. The component in our case is this is the selection of the cereal box. And in a nutshell, what that means is this is what you're doing. So the component is what you are doing. What do you think your outcomes are? What you get. This is what you get. So your outcomes are what you actually get. And what are we going to get in our outcomes? Cards. So our outcomes are the different cards we're going to get. A trial. So the next thing, a trial. A trial is each time you perform an outcome. Is each time you get a different outcome. So this is each different outcome. And we talked about response variables in linear regression. What is a response variable? From linear regression, what was a response variable? You had two variables. What were they in linear regression? Explanatory and the response. What was the explanatory variable? The independent variable, x, right? What was the response variable? The dependent variable. So what does that mean to be a dependent variable then? Yeah, so and now, so when we apply to this, then our response variable is going to be what we call the variable of interest. This is the variable of interest. In our case, what are we interested in? Are we interested in just the cards, though? We're interested in what, actually?
Oh, right.
How many boxes it takes us to get.
To get those ones.
Thank you. So our response is how many boxes we need to complete the collection. And generally your response variable in these type of things will be something like this. How many on average, those type of things, all right? So let's say things like that. So here are the steps that you're going to follow to conduct a simulation. And we're going to start off very broad. We're going to get specific as we do it, though, all right? So you're always going to first identify the component. Why are you doing the simulation? Or what is this? What are you actually simulating? Means is what this is. Identify the component. What are you simulating? The second thing you're going to do, you need to explain or have some kind of procedure of how you're going to model outcomes. You're going to explain how you model outcomes. And what this generally means is you're going to associate probabilities. Now, this means you're going to associate probabilities to different outcomes. In our serial example, did they give us probabilities? Yes, they gave us a probability for each outcome, right? For a Mickey Mouse card, for a Goofy card, and for a Donald Duck card, right? The next thing you're going to do is the third step. You're going to explain how to simulate a trial. So this means, in our case, what's our explanation of our trial is going to be? What is a trial here? That's you doing what? You going buy a box of cereal, opening up, and pulling out a card. You got that? That's the actual trial. So let's stop there and let's start writing out what we're going to do. So here's how you're going to set this up. You're going to make a table like this. All right? Always start with a table. Trial number comes first. What are your outcomes going? Your outcomes are going to be whatever you open in your box, right? You got that? Everybody understand that? And then the other thing you're going to add, the fourth thing I should add down here is, what is the response variable? Like that. What is the response variable? What are you actually interested in knowing? When do you stop? When do you stop one trial and start another? That's what this is saying. So this is when do you start and stop. So here's how this works. For this problem, let's do this together. We're going to do 3 trials of this. All right? 3 trials. And we're going to use this number table down here to do it. This random number table right here. This is called a random number table. And it's random because these numbers right here are generated randomly from some kind of computer program that made to a table. Alright? When you start this, here's how you're going to start it. You always start by identifying the component. So what are we doing here? Well, what are we going to simulate? What are we simulating? What are you actually simulating though? That's the actual response. What are you actually simulating? What are we doing? What are these numbers represent? What are these numbers going to represent for what we're talking about? Boxes of what? Cereal. So what are you simulating? We're not going to buy that many boxes. So what are we talking about? We're going to simulate buying boxes of cereal. The actual simulation itself is buying boxes of cereal. And the next thing we're going to do is we're going to associate outcomes to each box. Like, what do we expect to be in each box? So we'd expect how many Mickey Mouse cards will be in a box? Well, it says what? 20%. So we'll say, here's what we're going to do. Mickey Mouse is 20%. Right, like this right now. Goofy was 30%, which means that Donald Duck was what? 50%. And now what you're going to do is this. In a random number table, you have digits 0 through 9 for a total of how many digits? 10. 10 total digits. Everybody understand that? Which breaks up nicely into these percentages. So if I want to show 20% of the numbers, how many numbers would I use for Mickey Mouse? If I want to show, how many digits do I have in this? How many digits do I have? 0 through 9. Everybody understand that? That's 10 digits. Everybody got that? So, what is 20% of 10 digits? 2 digits. We understand that? So, I'm going to let 2 digits represent Mickey Mouse cards. 2 of my digits in the table represent Mickey Mouse cards. I need to set those 2 digits. I'm going to say those 2 digits are the numbers 0 and 1. And what that means now is this. If I look in this table and I say 0 or 1, what does it stand for? A Mickey Mouse card. Everybody got that? That's what this stands for. How many digits do I need to let Goofy be? 3. So what numbers can I make that be? 2, 3, 4. All those represent Goofy. So if I say 2 or 3 or 4 in the table, what does that represent? Goofy card. How many do I need Donald Duck to be? That's 5, 6, 7, 8, 9.
Wait, those represent boxes?
The numbers represent boxes, but what's inside the box though? What's inside? What are we interested in inside the boxes though? We're interested in what? The cards that belong in the box. We're simulating opening boxes, but the actual outcomes are going to be the cards in the box. So here's how this works. Anytime you start a simulation now, we're simulating a trial. We're going to, the third step says to explain how to simulate a trial. So your third step is explain how to simulate a trial, all right? That means first thing you're going to tell me how are you going to start this. We're going to start at a certain row. So you'll start with start row. We'll start at row 1. When do I stop? When do I stop? When does the trial stop? When I get all 3 cards. So I'm going to start at row 1, stop when I have a number. God, I'm trying to give myself more room. And here you're going to stop when you have a number from 0, 1, a number from 2, 3, 4, and a number from 5, 6, 7, 8, 9. You understand that?
No.
So why not? How do you get all 3 cards? You have to buy as many boxes as you can, actually. You just have to make sure. You have to get a number from where? You have to get a number from where?
0, 1.
That means you got what kind of card?
Oh, okay, I get it now.
You sure?
Yes.
Okay. So stop when I have a number from, we'll say from each group.
Yeah, you should say it like that.
I'm sorry. Stop when you have a number from each group. So here's how you start this. On this table, you're going to say start. Write start above it. So write start above this table. And here's what we're going to do. 1, what does that 1 represent? That's a Mickey Mouse card. So we'll circle this because we're going to keep it in the sample. We're going to keep it, and it's a Mickey Mouse card. And up here where it says outcomes, draw an M for Mickey Mouse. That's our first outcome, right? Everybody got that?
Oh, so you're just going to take the first number and the bottom one?
Yes. I'm just looking at the number. So that's Mickey Mouse. What's the next one going to represent? This 7 is a what? Donald Duck. Do I want that one in the sample? Yes, because that means that's a different card, right? So, Donald Duck. The next one is a what? A Donald Duck. Am I going to keep that one? No, but I still need to write it up here because that means I got a Donald Duck card again. That means the third box that I bought was a Donald Duck card, right? What's the next one? So this 6 is a Donald Duck as well. And notice the ones I'm not taking, the ones I don't want or that I'm not interested in, putting a slash through them. The 8 is a what? Donald Duck. So I have to keep going, right? The 2 is a what? 2 is a Goofy, so I keep that one. And then I stop. So when you stop something, here's how you're showing you're stopping. You're going to show you're stopping by drawing a line like this. That line means you stop. That's your first trial. The question is this then. What is the response variable here? We said the response variable was how many boxes do we need to get the collection, right? So how many boxes did it take us to get this collection here? 6. And now what do you do next? How do you do the second trial? Start over and do it again, right? But you started where you start where you stopped at, which was at this mark right here, right? Start right here. So what would come next? So this is a Goofy card. Then you have what next? The 9 is a Donald Duck card. The 4 is a Goofy. The 3 is a Goofy, right? The 6, Donald Duck. The 1 is a what? Mickey. And that means you can do what there? Stop. How many boxes? Do the last one. Yeah, so go ahead and find this one now. I think this one's the longest actually. Oh wait, I should have stopped here before. I got. Here, go ahead. Hey, you should. I'm not gonna write all these out because what you're really doing is I'm just showing you how you know when to stop. You understand that?
But do you want to start?
You don't have to. I mean, you don't have to because I feel like y'all got the idea. You got the idea of what we're doing, right?
Yeah.
That's why I wrote this outcomes box. But for this one, how many do you need to get to there?
13.
So this is a total of 13 boxes. And now the question will generally say something like, on average, how many boxes would you need to buy? So how would you find the average? Add them all up and divide by 3. So on average, you need to buy, that's 25 divided by 3, which is about what? About 6? I mean, yeah, 8 or 9. About 8. So it's 8.333, right? So how many would you have to buy on average then? About 9. You have to round up here. Always round up when you have fractional parts like this. So about 9 boxes is how many you have to buy before you get them all. Now, I put this section on there about the AP test itself. Simulations rarely show up on the AP exam, but when they do, here's what they're expecting you to do. You need to be as descriptive as possible when you're explaining your process. It's all about developing a process. Alright? So you need to be as descriptive as possible when you're developing that process. That includes simulating the 4 steps that I gave you right here. That includes these 4 steps right down here. You need to make sure you go through those 4 steps. You always need to make sure you tell them where you start, where you stop. So indicate where is the start, where is the stop at, alright? When they say, it says graders will be looking for your count, here's your count. Here's the count. This summarizes what you did for each trial. Everybody understand that? So it's counting the trials for you, alright? And it's also looking for this right here. We didn't talk about this, but when you set this up, you need to establish where you're doing this with replacement or non-replacement. And are duplicates allowed? And I'll show you what that means in the next example, are duplicates allowed. So let's look at the next one. This one says 57 students participate in the lottery for a particularly desirable dorm room, a triple with the fireplace and private bath in the tower. 20 of the participants were members of the same varsity team. When all 3 winners were members of the same varsity team, the other students cried foul. Use a simulation to determine whether all varsity team outcomes could reasonably be expected to happen if everyone had a fair shot at their room. Everybody got that? What's the probability I actually have a shot at this room right now? Let's talk about that real quick. 1 in what? 1 out of 57 chance you have a shot at the room. You understand that? What's the probability that if there are 20 varsity members in there, 20 varsity members, that all 3 of them are, when you select the 3 people, they're all going to be varsity? That means you get no non-varsity people here. Mathematically, what would that be? We can calculate that. How many varsity members are there? So that's 20 out of how many total? Times. We take 1, what's left then? 19 out of 56, go down. Times what? 18 out of 55. What does this mean? This means you took all what? All three of your people were what now? Varsity. So how do you calculate this? Just multiply that. That probability is 20 times 19 times 18 divided by 57 times 56. That probability is this right here. 0.03. So there's about a 4% chance that mathematically, that all three players will be varsity. I got that? So if it actually happens, do people have a reason to cry foul? Yes or no? Should people think that it's rigged? That's what they're saying. Would you think it's rigged at 4%?
No.
It's possible, right? Would you be upset at 4%?
No.
If you weren't a varsity player and you didn't get this, would you be upset?
Yeah.
Yes. Because mathematically 4% seems like it's really small, right? Let's simulate this process. So what do these numbers represent when we start the simulation? What do they represent? What do the numbers represent this time? Last time, what did our numbers represent? They represented what? Box of cereal. What are these numbers representing? They're representing students. Good. So let's talk about this. The numbers represent. Let's start here by just defining what the numbers represent. The numbers represent students. So what does a component consist of here? What are you actually simulating? Last time we simulated selecting boxes of cereal. Well, this time what are we selecting? Thank you. So the component we're simulating is we're going to simulate the selection of students. That's the first thing. The second thing, now we need to assign probabilities to each one of these, right? Everybody understand that? Or we need to assign our numbers to this. So, varsity players, here's how this is going to work. The first time we did it, they gave us percentages, right? Did they give us percentages here? No. They showed us how many varsity players we had and how many regular students we had, right? So we'll say varsity and we'll say non-varsity. There are 20 varsity players. Everybody got that? Sorry. There are 20 varsity players. Everybody got that? So we need to assign the numbers for 20 varsity players. How can we do that? This time, we're going to use two-digit numbers. We're going to allocate 2 digits for each number. So varsity players are going to be the digits. Let's do 0, 0, 00. We're gonna stack them together like 0, 0, 2 through what? To what number? Not 20, but 19. Why 19 and not 20?
Oh, because you're already adding.
You're counting 0, 0, 0. So 0, 0 through 19 is going to be. So what are we going to do when we go through the table? We're going to look at these as double digits when we go through the table now. Before we looked at them as a single digit, right? Now we're looking at them as double digits. Non-varsity will be what then? They'll still be double digits, but it'll be what numbers? From 22, 50, not 57, 56. If you don't like this assignment, you could do 0, 1 through 20.
Why didn't we do that?
Because I just did start at 0, 0. You could do 0, 1 through 20. Because why can't you do single digits? Well, look, if I did single digits, what's this first one going to be? Is it a 1 or a... So if I do single digits, I can only do numbers from what? 0 through 9, right? Can I do player... So how would player 10 be included in the sample? How would player 11 be included in the sample? You understand that? So why'd I have to do double digits now? When I look at this first one, what is this first number going to be? 17. Is he in the sample? Yes. If I look at... Like, you can do single digits. If you combine 0 and 9 here, what do you get? 9, or 0 and 6, you get 6. Y'all understand that? Yeah. So you just have to use double digits this time for this.
How it works out, you can get like a 6 or a 9, 0.
Do what? The number of players you have in here. So look, if you would have had more than 100 students, what would you have to do? You have to use what there? Triple digits. Y'all got that to give everybody a fair.
9, 0 or like 7, 9 or. What about this?
Let's talk about that. Good. So if we get numbers outside of this range, what are we going to do? We're going to exclude the people outside of the ranges. I got you. You need to write this right here, though. Exclude all players outside of this range. That means we're not going to worry about those players if we come across them. When do we stop this? When do we stop? When we get what?
3.
When you get 3 numbers from inside the range.
So 3 from anywhere inside.
Yes, when you get 3 from inside the range. Question. Can the same number show up twice in the sample? What do we do when we get the same number twice in?
Exclude them.
Exclude repeating numbers. You're going to exclude repeats as well here. Last part of this I want to write today. What is the response variable for this? What are you interested in knowing here? What are we actually testing? Why do we even do the simulation? Because we wanted to know if all 3 players could be what? Varsity. So you're looking for how many samples would include what? Yes. So you're looking at... No, you would do it. You would look at how many samples. You would do a number of trials this time. So say you do 10 trials. What are you looking for? How many of them include all 3 varsities? So all samples that include. Yeah. All samples that include all 3 varsity players. So to finish this, here's what we're going to do. We're going to stop this simulation when we have 3 players that fall inside these 2 ranges right here without repeating. So, and we're interested in how many of those samples will include all 3 varsity players. So I'm going to do a sample. I'm going to do this. Generally, if it doesn't tell you how many to do, we're going to do 5. Generally, it'll tell you how many to do for each one of these. So I'll start mine. Will look like this. It'll look trial number. So we're going to do 5 trials here. I'm going to write out the outcome. And the response variable is, the response here is, does it contain all varsity players? So I'm going to answer that by saying yes or no. So please look here. I'm going to start this at row 1. So I'm going to start here. And I'll stop this. My stopping rule is when I get 3 players from within the ranges 0, 0 through 56. So that's when I'll stop. So let's write that out. Or 3 students, I'm sorry, not players. So starting at row 1, first student we have is student 17. Then we see the number 86. You're looking at 2 of the determinants, double digits. 86 is not going to be in the sample because that's larger than our largest number, which is 56. So we'll put an X through it. 82, put an X through it because that's larger than that. Then you have 49 is in the sample, and 43 is in the sample. So this is stop. So it looks like we have, and I'm interested in what are they? Are they varsity or non-varsity? So I have a varsity player, non-varsity, non-varsity. Did I get all 3 varsity players? And the answer here is no. So we'll start the process again. In the sample, started 61, not in the sample. 79, not in the sample. 9, that's in the sample, it's a varsity player. 6, in the sample, it's a varsity player. 56, in the sample, non-varsity. So we have varsity, varsity, non-varsity. So again, this is going to be another no for all 3 varsity players. Do it again. 87, not in the sample. 96, not in the sample. 41 is a non-varsity player. 88, not in the sample. 83, not in the sample. 41 is a non-varsity player, but we've already used this person here. So we're not going to take him again because he can't come in the sample twice. So we're not even going to look at that. 97, 98, 34, is a non-varsity player. 85. 46 is the last person we need. So there we're going to see, we're going to stop after that. That's 3 people. We have 3 non-varsity players in this sample. So again, that's another no. Do it again. 81, 68, 54 is in the sample. 85, 19 is the varsity player in the sample. 23, the non-varsity player in the sample. So this time you have non-varsity, varsity, non-varsity. And so again, your answer here is no. So it's not looking too good. Let's look at the next row. So this one you have 85. 50 is a non-varsity. 34, non-varsity. 5, varsity. So here you have non-varsity, non-varsity, varsity. So again, that's no. So we see after 5 trials, we've done this 5 times, we see that so far, there have been no selections of all 3 varsity players. So based off this simulation, is it fair or is it justifiable to say that it's hard to believe that all 3 players came from the same varsity team if it was random selected? Then yes, you could say that. Because so far for our simulation, we have no varsity player, no all varsity teams in any one dorm room.